Hi class, this is course 2, lesson 18. We're going to talk about polygons and the terms similar and congruent today. So what do you need to know? A polygon is made of segments, so we have straight sides. It's also closed, so the sides meet. There's no open edges or no ways into the shape, and I'll explain that here in just a minute. 2D, two-dimensional, not three-dimensional. So what this means is that we have a flat shape. Look at the examples, and I want you to copy these down in your book, in your notebook. These examples on the left, these are polygons. Okay, so notice that we have, and they don't have to be filled in. I just did that so you could see them on this video. So we have segments on the outside here. They all connect, and nothing is curved. Okay, so it's straight edges, and it's flat. Now this one down here, this polygon, we do have a little indentation, but that's okay. You can't get inside this shape, so all the edges meet with another edge. So it's made of segments, it's straight, straight sides. They all meet up with another one, and so it's closed and it's flat. So these on this side, these are examples of what is not polygons. Okay, notice, let's start at the top. Made of segments. This is not made of a segment. It is closed, but it's round, so this is not segments. Okay, and I hope you understand that segments have to be straight, and this outside of the circle is rounded. This figure here is made of segments, but right here there's an opening, so this is not closed. So you see how the segments don't meet with another segment, so these are open-ended, so not closed. And then this is a cube, and this is three-dimensional, 3D. So that's why these are not polygons. Okay, I'm going to flip the screen here, and I'm going to move this up first, so hopefully that didn't cause any problems for you, but we're going to talk about how you classify polygons. So you can classify polygons by the number of sides, and there's a lot that you need to write, and if you can't fit this all left to right on your paper, then make a couple columns, but you will need to know this. So if you have 3 sides, you have a triangle. If you have 4 sides, you have a quadrilateral. 5 sides is a pentagon. 6 sides, hexagon. 7 sides, heptagon. Notice there's 1, 2, 3, 4, 5, 6, 7 sides. 8 sides is an octagon, and this doesn't need to be filled in. It's just the only example that I had at the time that I made this. So as long as there are 8 sides, it's an octagon. Also notice that 4 sides could look like a square or a rectangle, but I chose to show it in a shape, in a polygon that you weren't maybe as familiar with, because these can be they can look any way. Even this pentagon or this hexagon, they don't have to look like this. As long as they have 5 sides, it's still a pentagon. Okay, so there are a couple more that you need to know. 9 sides is called a nonagon. 10 sides is a decagon. 11, undecagon or undecagon. 12 sides is dodecagon. And then after that, we just name them by the number of sides and then tack on the word gon. So it's a 13 gon, a 14 gon, and so on. So if I had one that was, 58 sides, it would be a 58 gon. And that's just an example. You don't need to have that in your notes. Okay, so here's some vocabulary for you. If we say we have a regular polygon polygon is a polygon with all sides congruent and all angles congruent. Okay, so that doesn't help you much if you don't know what the word congruent means, right? So, congruent means same size and same shape. So in other words, they're equal. They look exactly the same. They're like a copy of it. So, congruent in this case here, in a regular polygon, we're saying that all sides are congruent. So all sides have the same length. So in this example, it's a regular polygon and it's a triangle because there are 3 sides. But notice that all 3 sides are the same length. Now, another way the book might show it is that they might have like a single mark on all 3 sides. That means that all 3 of those sides have the same measure. We also know that all angles are congruent, and so you might have a little line here. That means the angle, and then you might have, we'll just put 2 for good measure here. You might have 2 symbols here. Okay, notice that the 2 and the 2 and the 2, those match up. That means that those are all the same. So you might want to make a little note here that tells you that that's what those marks mean, that they mean the same. They're the same. They're congruent. Okay, so again, congruent means same shape, same size, and same shape. So here's an example of what is not a regular polygon. This is still a triangle, but notice our side lengths are 3, 4, 5. That's irregular. All of the sides are not the same length. All of the angles are not the same measure. Okay, I'm going to put this back up here again. I need to pull that up and we're going to flip to the next page. Okay, so another way to identify polygons is by the vertex letters. Okay, so the vertex, remember, is the point where 2 sides of a polygon meet. So they're going to form an angle, and at the center of an angle is a vertex. So if we wanted to name this polygon, we would start at any vertex, so any vertex, so any point. I could start at D, I can start at E, I could start at B. And then we list them in the order either clockwise or counterclockwise. It doesn't matter. So if you say that this is polygon, we can start at B and go clockwise, and we can say this is polygon B, C, D, E, A. Okay, or we could start at D and go counterclockwise against the way the clock moves. D, C, B, A, E. Okay, so we could start at any letter and go clockwise or counterclockwise. So there's 2 for each starting point. So there would be 10 different ways that we can name this polygon. Just out of curiosity, can you name this polygon? How many sides does it have? Or classify it by name. How many sides does it have? It has 5, so that is a pentagon. Okay, I want you to sketch hexagon LMNOPQ. And then I'm going to click over here and we're going to show you your answer. So do that, pause the video, then do that, and then resume, and you'll see the answer here. So the answer, the hexagon that I sketched here, I started at this vertex and went clockwise, LMNOPQ. As long as your letters go in that order, either clockwise or counterclockwise, and you have 6 sides, you've done exactly what you were asked to do. Now, alright, I'm going to zip this back up here. We need to talk about the words similar and congruent. Similar figures have the same shape, but are, similar figures have the same shape, but are different size, okay? Oh, I know, this should have said can be, but, because they don't have to be, okay? They could be the same size, and I'll explain that in a minute. So think about pictures. If you copy a picture into Word, when you grab onto the corner, you can make it larger or make it smaller. And when you're doing that, you're just enlarging or shrinking, okay? And that keeps the same size, or keeps the same shape, sorry, but it has a different size. Okay, so here's an example. These two triangles, one is larger than the other, but they still look proportionate. Okay, so like the base length and the side lengths look like I just cut them in half. Okay, roughly. Well, all I did was grabbed onto the corner of the triangle. I grabbed this and went, okay, as long as I do that at that right pace, I'm going to have similar triangles. Now notice how this triangle over here is not similar to these, because the base, I mean, these almost look identical in size. That's not what we have over here. We clearly have a shorter side and then two that are the same length. So this is not going to be similar. Okay, so this is not similar to these, but these are similar. Okay, to each other. Now let's talk about congruent. We already talked about it a little bit. So congruent figures have the same shape and the same size. And here's the thing, if they are congruent, they're also similar automatically. So if you know that they are identical, then they're similar. And so the example here is that it's something that you would copy. So this triangle and this triangle, they're just identical, right? They're copies. So these are congruent. But notice this guy over here, he's not like either one of these. He doesn't match up. I can't, if I move this triangle over here, it doesn't match up, right? You can still see the other one underneath there. Even if I were to rotate it around and move it, that doesn't help either. Okay, because I can spin it. If I can spin it and it will look exactly the same, then it is congruent also. It doesn't matter the orientation or the way that it looks on your page, as long as they, when you rotate it, that they are the same. Okay, so now, if we have congruent polygons, we have corresponding parts. We also have, in similar polygons, we also have congruent parts as well. So we should make a note here. So if they're similar, match up from one congruent or similar polygon to another. Okay, so in this case, I'm going to tell you, now this is important. If I wanted to tell you that this was a triangle, you would make a little triangle and then pick one of the vertices and then name it. So that I like to start alphabetically. Triangle A, B, C. Okay, and now I'm going to tell you that it is congruent to, and you're going to see an equal sign with a little squiggly line, let's just call it, above the equal sign. That means congruent to. Congruent. And similar would be just the little wavy part. Okay, so if it was just similar, it wouldn't have the equal sign. But I'm going to say that triangle ABC is congruent to triangle Y, Z, X. Okay, so I'm just starting here and I'm going around. And I can do that because, oh, hang on just a minute. Let me select all these and group them so that when I spin it, they'll all go together for you. Okay, so if I spin this triangle, I can make it look just like that one, right? Okay, and it's off just a little bit, but that's because I didn't spin it the correct way. Okay, so you know that they're congruent. Now, we need to start identifying the corresponding parts. So they're the ones that match up with each other. So, what we would say is we have 3 different angles, and they're all going to correspond to the angle in the other triangle, and we have 3 different side lengths, and they will correspond to the sides in the other triangle as well. So we can say angle A corresponds to angle, whoops, I meant angle, and which one was like where A was in this triangle? Would be angle Y, and then angle B corresponds to angle Z, and angle C corresponds to angle X. Now, look at this. If we have this right, triangle ABC is congruent to triangle YZX. Look at A matches with Y, B matches with Z, and C matches with X. Okay, and we can use that similar logic to help us map out the side lengths. So we'd have segment AB is going to correspond to segment YZ, and segment BC is going to correspond to segment ZX, and segment CA is going to correspond with segment XY. Okay, now look again at our triangle. We have AB. AB is right here, corresponds with YZ. BC, the last 2, is going to correspond with the last 2, ZX. And then we'd go C to A, X to Y. Okay? So that's how corresponding parts work. You match up the ones that are the same in one triangle to the other. Okay, and I know that this can be a little bit confusing, but if you refer to your notes, and page 123 has a couple really good examples for you, and we will do a small activity, short activity in class with this concept too. Okay, so jot down any questions you have, and we'll talk about them in class. Thanks.